everyone, welcome to the MOOC lecture series, an initiative taken by LG Institute of Pharmacy. Myself, Tosha Pandya, Assistant Professor, Department of Pharmaceutical Technology. In this session, we'll be talking about the partially miscible liquids. So let's begin with the session. First of all, what are partially miscible liquids? So the partially miscible liquids are also known as the conjugate liquids. Okay, so this type of liquids are the one in which the solubility in one another is limited. Okay, the mutual solubility of two liquids in one another is limited. So based on the miscibility, which is dependent on the temperature, we can have four types of system. System number one, in which the solubility will increase with increase in temperature, like the phenol water system. System number two, in which the solubility will increase with decrease in temperature. That is the water TEA system. And system number three, in which the solubility will increase also and decrease in temperature. That is the nicotine water system. And the fourth system, in which the solubility is not affected by the temperature. So we will see each of the system in detail. Okay, so the effect of temperature on the degree of miscibility in this system is described by means of the phase diagrams. Okay, so in the phase diagrams, which is a plot of the composition versus the temperature in degrees Celsius, will give you the miscibility temperature of the two liquids. Now, what is miscibility temperature? It is the temperature at which the two conjugate liquids are mutually soluble, where this type of systems find application. Now this is required when we need to decide the proportion of the two liquids during the formulation when one phase system is required. Okay, and it's also used for testing the purity of the liquid. So the first system, which is phenol water system, here you can see the phase diagram. It is the composition versus the temperature. Okay, the composition at 34% weight by weight phenol, as you increase this composition, that is phenol in water, here you will have more of phenol, whereas here you have more of water. Okay, so you can see below 66.8 degrees Celsius and the two liquid phases are existing, whereas above this you have one liquid phase system. The critical solution temperature or the upper constellate temperature is the maximum temperature at which the two phase region exists. Okay, in the case of phenol water system, it is 66.8 degrees Celsius, above which the phenol water system will exist as one phase. Okay, so while we are formulating phenol water system, we can choose the temperature above this in order to get one phase system. The next system is the TEA water system. So what happens here, the solubility will increase with decrease in temperature. You can see here that below 18.5 degrees Celsius, you have two liquid phase, whereas below it, above 18.5 degrees Celsius, you have two liquid phase, whereas below 18.5 degrees Celsius, you have one phase. So in the TEA water system, it has lower consolidate temperature, which is the minimum temperature at which two phase region will exist. Okay. The third system is a nicotine water system, which is very interesting. It is having both LCT and the UCT, means the solubility will increase with increase in temperature also and with decrease in temperature also. So this between 208 and 60.8 degrees Celsius, two liquid phase exists. But above 208 and below 60.8, you will have one phase system. So we have two temperature ranges where we can work upon when we want to use the nicotine water system. Okay. Now, how the foreign substances will influence the mutual solubility. The foreign substance, if added to the two-phase system, will form a ternary phase system, okay, three-component system. Now, this can influence the LCT or UCT depending on whether the added substance will cause the salting out or the blending. What is salting out? If the added substance is soluble in only one of the two phases, it will salt out the other phase. Okay, and it will lead to increase in UCT or increase in LCT. Whereas if the substance is soluble in two phases, it try to mix together the two phases, and therefore it will decrease the UCT or the LCT of the system. The example is the sodium chloride. If NaCl or naphthalene, NaCl which is soluble in water and naphthalene which is soluble in phenol, if it is added to the phenol water system, what will happen? It will salt out the other phase. Okay, and it will increase the UCT. But if we add a substance which is mutually soluble in phenol water system, like the succinic acid, it will blend the two phases and therefore it will lower the UCT. So I hope you are clear with the partially miscible liquids, its importance of partially miscible liquids, the phase diagrams, and the influence of the foreign substances. Thank you all. Please do like, share, and subscribe our YouTube channel Pharma Ignite, and do not forget to press the bell icon to get the regular notifications so that you do not miss out any of the topics in this chapter. Thank you.